All right, so we're going to look at some example problems to help us figure out how to solve some of the problems we may have had issues with on our quiz. The first two problems we're looking at here are solved by factoring. And so instead of looking at the original problems, because I want you to work through those and see if you can get the right answer, we're going to look at the example problem. And so I've created an example problem here. I've got this problem x squared minus 14x plus 45 equals 0. The leading coefficient here is 1. So I'm just going to look for the factors of 45 that add up to be negative 14. Well, the factors of 45 that give you negative 14 are going to be negative 9 and negative 5. So you've got x minus 9 and x minus 5 equals 0. At this point, you want to set each quantity equal to 0 and solve. So x minus 9 equals 0 and x minus 5 equals 0. For x minus 9, you're going to add 9 to both sides, and you get x equals 9. So there's one answer. For the second one, you've got x minus 5 equals 0. You're going to add 5 to both sides, and you get x equals a positive 5. So your two solutions are 9 and positive 5. So for the next two problems here, we have problems where we're talking about finding the axis of symmetry, vertex, or any other key points for a quadratic equation. So for this one, we're going to use the quadratic equation f of x equals 2x squared plus 4x minus 6. For this problem, if we're looking for the axis of symmetry, we need to remember one thing, that equation is x equals negative b over 2a. Well, negative b in this case for the problem we're looking at here would be negative 4 over 2 times 2. Well, that's negative 4 divided by 4, which is a negative 1. So your axis of symmetry is x equals negative 1. This is also the x value of your vertex, so we know we've got a negative 1 to start with. To find the y value, we plug this back into the equation. So we're looking at 2 times negative 1 squared plus 4 times negative 1 minus 6. Negative 1 squared is 1, so we've got 2 minus 4 minus 6. Well, that gives us negative 8. So the y value of our vertex is negative 8. So that's our vertex coordinates. Let's say for this problem that we started with, we also want to find the y-intercept. Well, remember, the y-intercept is the c value of your equation, or where your graph crosses the y-axis. So for this problem, your y-intercept is just the point 0, negative 6. And in order to know if it's a max or a min, just think about how we'd graph this. So I'm just going to make a nondescript coordinate plane. My vertex is negative 1, negative 8, so it's down here. And that means my axis of symmetry runs through there. I have the point 0, negative 6, which would be up here. But I can mirror this point over to the other side, which would be here. And so my parabola looks something like this. Just a real quick graph. And because this is the low point of the parabola, then that means we're dealing with a minimum. In this problem, we're looking at another example solved by factoring, but this time we have a leading coefficient. So we're going to look at the example problem, 3x squared plus 8x minus 16 equals 0. When you have a leading coefficient and you're trying to solve by factoring, remember this is where you use slide, divide, factoring. So we'll slide our coefficient back through multiplication. We're going to get x squared plus 8x minus 48 equals 0. Factors of negative 48, or two numbers that multiply together give you negative 48, but add up to a positive 8. Well, that's going to be positive 12 and negative 4. Now you have to try to divide by your leading coefficient. So we're going to try to divide 12 by 3 and 4 by 3. If it works, go ahead and divide. So x plus 4 is what we get for our first quantity. And the second one, it doesn't work, so you bring it back out in front, and you get 3x minus 4 equals 0. Now the last part of this problem would be to set each portion equal to 0 and solve. So this is our factored form, which would be here. Now we're going to solve this. We're going to take x plus 4 equals 0 and 3x minus 4 equals 0. Well, I'll subtract 4 from both sides in the first one, and I get x equals negative 4. Here I'm going to add 4. I've got 3x equals 4, divide by 3, and you get x, there we go, to equal 4/3. And those are our two answers. In this problem, we're looking at taking a real-world problem or real-world situation, taking the equation, and then finding the time to the max height and the height at the max. Instead of using the original equation, I've changed it, and we're going to use this equation here. So we're using negative 16t squared plus 48t plus 8. It's only slightly different than the other one, so we should be able to figure out how to correct our original problem pretty easily. So remember, time to max height is just another way of saying your axis of symmetry value, or x equals negative b over 2a. Well, in this case, negative b would be negative 48 over 2 times negative 16. Well, that's a negative 48 over negative 32, which is going to be 1.5. So that means the time to max is right around 1.5 seconds. To find the height at the max, all we need to do is plug in the 1.5 for x. So, or for t in this case. So we've got negative 16 times 1.5 squared plus 48 times 1.5 plus 8. If we plug this piece into our calculator exactly like that with the parentheses and everything, we should get that the height is 44 feet. So after 1.5 seconds, the fountain has a maximum height of 44 feet. All right, and the last problem talks about solving using square roots. So we're going to look at our example problem here, 3x squared minus 27 equals 0. Keep in mind, when solving with square roots, the key is to isolate your squared term. So I need to get everything away from the x squared. So I will add 27 to both sides. I've got 3x squared equals a positive 27. Then I'm going to divide by 3. And I've got x squared equals 9. Now that the x squared is all alone, I can square root both sides of the equation. And I know that the square root of 9 is 3. But because I'm dealing with solving by square roots, I know that I have two answers, a positive and a negative version. So it's going to be plus or minus 3, or you can say x equals negative 3 and x equals 3, so x equals 3 or negative 3.